Hi, welcome to the presentation for protection from ransomware in the cloud. This is going to be discussing how AWS services can help you to mitigate risk. For today's session, we're going to be covering a number of topics. So we'll have the speaker introductions. We'll go over cybersecurity risks today, how AWS can assist you in that. We'll talk about a few case studies and use cases, and then how you can get started in helping to protect your investments and infrastructure through the use of tools provided by AWS, and then finally, how TechStream can help. So for today's webinar, we have myself, Troy Allen. I'm the VP of Cloud Services with TechStream, and joining me today will be Shravan Rajuraju, who is a partner solution architect with Amazon Web Services. So at TechStream, I oversee all of our cloud practices, including AWS, helping our customers to not only adopt AWS cloud services, but migrate their workloads and protect themselves from incidents such as cyber attacks, ransomware, and DDoS. So, Sravan, thank you for joining us today. I was hoping maybe you could give us just a little bit of your background.
Yep, thanks, Troy. Hi, my name is Shravan Rachiraju. I'm a partner solutions architect at Amazon Web Services, and I've been with Amazon for over 4 years. My team specializes in helping customers set up their disaster recovery environment by leveraging best practices and avoid any gotchas or landmines that can often stall a full recovery within their set RTOs and RPOs. So let's get started. Let's discuss more about common disaster recovery challenges. Back to you, Troy.
Yeah, perfect. And, as we indicated, the topic today is really around cybersecurity risk and, what organizations are being faced with. And the tool sets that we're going to be talking about really do much more than that, as you'll learn as we go through our session. From being able to perform disaster recovery, having block level replication, really provide you with a safety net that you really need. So when we look at how to best manage cybersecurity risk, you really need to have a plan built. And there's a few key action items that you want to go through to ensure that you're going to be successful in protecting your data, your applications, your systems, and your sense of mind, in these changing times that we're in. So the first thing is you've got to identify what needs to be protected. Production systems for certain need to be protected. You're going to have different data elements that are going to have to be protected, but also the applications themselves. And in some cases, you may also want to protect certain elements of your non-production environment, especially if those are environments where you're building out your code deploy and methods and so forth. You need to understand through the protection what type of controls and training you need to have in place for minimizing the impacts of those. So technology takes you a long way, but if you don't have the appropriate processes and people that understand the control mechanisms are in place and the technologies to work with, then you're still going to have problems with cybersecurity risks. So the technology gets you so far, but there's a training aspect that needs to be brought into picture with it. Now, in order to be protected as much as possible, you've got to have a good way of being able to quickly detect when there's been an event. That is going to drive how do you remediate from that, which is going to be the bulk of what we're talking about today, is that remediation section. But you need to know when an event occurred so that you can quickly go through your processes to restore back to a known safe spot. And this really comes into play with how you respond. What's your implementation plan to contain those attacks and then remediate back to a known point in time, which leads us into recover. What is the resiliency plan that you've put in store for data and other capabilities that might be impaired by these attacks? So with that, I wanted to turn it over and go through what are some of the common disaster recovery challenges that people face and how AWS really helps to support that. So, Irfan, I know you've got some ideas and things that AWS is working on. I was hoping maybe you could walk us through that.
Sure. So most common businesses have some sort of disaster recovery plan in place. However, it might not address the challenges that come with setting up a DR environment. Some of the most common challenges include diverse infrastructure and operating system type, meaning we can have legacy operating systems like a RHEL 5 machine or modern operating machines like Amazon Linux 2, RHEL 8, and any other newer operating system type. Machine compatibility issues can also present a few challenges. So, take an example when there is a DR event and you fail over your newer machine, the server that you're failing into should support your application. The compatibility should be there. And it's the same way when you're failing back. If you're failing back to a newer server, the compatibility should be there. The disk should be compatible. The server infrastructure itself should be compatible. Apart from that, your workload itself might be write intensive. If it's a database and the data in the disk changes continuously, that can present a huge challenge because you need to have a standby environment that is constantly replicating all those changes. Apart from that, having such a standby environment may present a very high cost, and it's just duplicating your environment. The licensing cost may be very high in this case as well. So there are other things as well, like using different DR tools for different applications. Say you have databases, you have your front end, and you have any other application that is just dependent. If you have a different DR plan for every environment, it's just going to be difficult to manage and juggle between those. And finally, the main thing to achieve is the RPOs and RTOs. So some common DR challenges include diverse infrastructure and operating system types, meaning we can have legacy operating systems like a RHEL 5 machine on modern operating machines like a RHEL 8 or an Amazon Linux 2. The other issues that can present are machine compatibility issues, meaning if you fail over or fail back into newer servers, that can present issues if it's not compatible with your current architecture. There are other things as well, like if you have a write intensive architecture like a database which is write intensive and there are continuously changes being done, replicating those changes into a standby environment is a little difficult, and maintaining a duplicate infrastructure can also present high licensing cost, and just maintaining those servers can also present high infrastructure cost as well. Also, having different DR tools for different applications can present a challenge because you have to juggle between those and have a plan in place where you migrate everything to a different environment when there is a failover event. And finally, the inability to achieve RTOs and RPOs to recover workloads within set time can also present a challenge and cost business a huge load of money. To overcome these challenges, AWS offers services that minimizes downtime and data loss with fast, reliable recovery of on-premises and cloud-based applications with affordable storage, minimal compute, and point-in-time recovery. So let's start with talking about how AWS can assist in this case. AWS currently offers two services: AWS Disaster Recovery Service, referred as DRS, and Cloud Endure Disaster Recovery, referred as Cloud Endure DR, to protect your workloads from a disaster. AWS Disaster Recovery Service is the next generation of Cloud Endure DR and is the recommended service to use for disaster recovery to AWS. Both DRS and Cloud Endure DR continuously replicate server hosted applications and server hosted databases from any source into AWS using block level replication of the underlying server. To provide more context, both services enable you to use a region in AWS as a disaster recovery target for workloads hosted on physical infrastructure, VMware vSphere, Microsoft Hyper-V, or any other cloud infrastructure. Both services can also be used for disaster recovery of AWS hosted workloads on EC2 instances to a different AWS region. DRS and Cloud Endure DR use a pilot light strategy, maintaining a copy and switch off resources in an AWS VPC, which is used as a staging area. When a failover event is triggered, the staged resources are used to automatically create a full capacity deployment in a target VPC used as a recovery location. You can initiate data replication back to your primary site and fail back once the issue is resolved or whenever you're ready. You can also perform non-disruptive drills to confirm the implementation is complete. During normal operation, you can maintain readiness by monitoring replication and periodically performing non-disruptive failover to AWS and fail back to your primary site via drills. Although AWS DRS has similar capabilities as Cloud Endure DR, there are some minor differences. Cloud Endure DR supports replication to all AWS commercial regions plus GovCloud region and the China regions. AWS DRS currently supports only 9 commercial regions. AWS DRS does not support all operating systems supported by Cloud Endure DR. AWS DRS is not HIPAA or ISO compliant, and AWS DRS doesn't support replication or recovery into AWS Outposts. However, the majority of these features will be available in future DRS releases. On the other hand, AWS DRS is operated from the AWS Management Console. This enables seamless integration between AWS DRS and other AWS services such as AWS CloudTrail, AWS Identity and Access Management, and Amazon CloudWatch. Access to public internet is not required for AWS DRS as everything falls within the AWS infrastructure, and on-prem to AWS connectivity can be managed through direct connect or private links. This is a significant security benefit for customers who do not want any public internet access. Both services provide continuous block level replication, recovery orchestration, and automated server conversion capabilities. Ideally, these allow customers to achieve crash consistent recovery point objective of minutes and a recovery time objective typically ranging between 5 to 20 minutes. And try back to you.
Excellent. I appreciate that overview of the services. So, again, as Ravan was talking about, dependent upon your particular environment and your requirements, there are two offers from AWS to support your needs. So, if we take a look at how other companies and organizations have utilized disaster recovery services, it'll start to paint the picture of how this become a very beneficial part of your infrastructure. So one example that we have is with Malibu boats, where they were able to recover within minutes of their critical server outages. The primary challenges that they faced were being able to gain enterprise level disaster recovery, but to do it within their existing budget. And that's always been, a hindrance, as we talked about earlier, for people wanting to do disaster recovery, especially in an on-premise environment. So by taking advantage of the features that AWS's disaster recovery services provide, they could establish that at an enterprise level while being able to remain within their budget and have the capability to do failover to a previous point in time in case of server corruptions or cyber attacks. And this really enabled them to have disaster recovery that is geographically distant from the primary data center. You know, when we look at the cost of on-premise disaster recovery, there's different stages that people will go through, and that they may have, within the same data center, a separate cage set up for their disaster recovery, where that protects you if you have an outage in a segment of that data center. It doesn't protect you if the entire data center is out. And sometimes it can be cost prohibitive to have a separate geographical location that you can perform DR against. And that's really the beauty of what AWS provides with this, whether it's because of an outage or it's because of a cyber attack that has occurred at the entire data center or just in the segment that your applications are installed on. And so the solution that Malibu Boats went through was to have a quick and easy continuous replication into AWS. So being able to take advantage of that block replication from their data centers into the cloud so that they can achieve those quick RTOs and RPOs within minutes as opposed to hours or sometimes days in a traditional on-premise DR configuration. And it also allowed them to save on provisioning servers and only utilize servers or spin those up on demand during a particular DR event or when disaster strikes them. And as we mentioned just a few moments ago, that recovery time objective, being able to do that in minutes was critical to their success. And some of the other primary AWS services utilized for the environments was the running all of the workloads on EC2 with Amazon EBS. Now, if we take a look at another example, Chick-fil-A Base Center Foods. Base Center Foods is the manufacturing facility that creates, it squeezes all the lemons and creates lemonades for all of the Chick-fil-A stores. And with this being based out in California, they had heavy concern about potential disruption in business flow, whether that was from uh, the physical elements of where they're geographically located, or because of their brand recognition throughout the world, potential cyber attacks. And so they needed a solution that would allow them to take their manufacturing execution software. These are the applications that run all the robots in the facility and all of the data associated with it, to have that protected and readily available in the cloud in the event of a security breach or a cyber attack or a physical outage in the data center, where it can still continue to be live and then restored once the physical location was back in good health. And in order to do that, they needed to have a recovery time of these critical systems in less than 72 hours. Using the AWS tools, we were able to achieve this in less than 2 hours of complete stand up of all 69 of their physical servers into cloud infrastructure, which was, really a key point for them and how quickly they could recover. And that helped them to be able to have an improved peace of mind because of the snapshot recovery for security breaches, ransomware, and obviously the natural disasters based upon the physical location of this data center. So, when we talk about protecting against cybersecurity, these same tool sets aren't just for ransomware and DDoS and so forth, but also just the general physical outages that most people think about from a disaster recovery perspective. All of this comes into the umbrella of what the services that we've been talking about today. So, when you look at what you need to do to get started, there's a couple of aspects you want to look at. The first is understanding what is your advantages and your disadvantages. So, when you look at on-premise, people are going to say, well, I don't have to go through the internet. And that's understandable. There's, times that you don't want to have to go through the public. And as Ravan had talked about with the Elastic Disaster Recovery Services, taking advantage of all of the AWS capabilities so that you can do this through secure VPN or through Direct Connect and protect yourself against sharing data over the public internet. So you have that through secure channels. So when we take a look at Cloud Advantage, you don't have the physical hardware cost. A lot of times when you're building out disaster recovery environments, it's a one for one for everything that you have in production. You're essentially paying double the cost for your production environment to have in either a hot or a warm standby. When you do this in the cloud, you're only paying for services when they're required, and it provides scalability on demand. So an example of this is you may have a smaller footprint that you're replicating to, but you can take advantage of other AWS services to potentially scale those vertically and horizontally. You're going to pay for the use, not the capacity, which is a key differentiator from a traditional on-premise disaster recovery. And this also lends itself to having that geographic redundancy. Being able to put this into a multitude of regions supplied by AWS means that you can very quickly and easily redeploy an DR event into another geographic location for that redundancy. And being able to automate this with blueprints that could be configured to spin up all the network and all the supporting information that's required for the actual applications means that your management overhead is greatly reduced. Now, some of the hurdles to do an on-premise disaster recovery is, obviously you're going to have an increase in capital investment. You're going to have very limited scalability that typically has to be one for one for your production environment. Your DR needs to keep in sync with that. You're going to have an overhead in your data center coverage, and there's going to be a higher cost associated when you need to go to a completely different uh, uh, data warehouse or geographic data center. Within the cloud, some of the hurdles that you might have is internet connection required, for the data. If we go back to the argument of the on-premise, I don't want to have to push everything through the internet. That could be achieved through direct connect or through secured VPN access. And the other aspect of this is that the data security controls are jointly managed. So you're going to have the security of outbound replication from your data center to the security of inbound replication into the cloud service. Now, the good news with this is AWS has done a lot of work on their network security and controls and actually make that very manageable for you to configure and maintain. Some of the things that we typically look at in protection against physical outages and ransomware and cyber security attacks really come into three main categories: my flexibility, my reliability, and how highly automated can it be. And with the AWS services, you can greatly reduce infrastructure costs. You're only paying for what you need when you need it. You have flexible and hourly billing that comes into play. You can have in time sub-second RPO and minutes for an RTO based upon configuration and complexity of your environments. But overall, you get a very simplified, unified solution for all workloads. One of the things that Servan had pointed out in his earlier discussion was some of the complexities of having disaster recovery. You might have different modes and models across the board. And with these tool sets, you can start to unify those and have standardizations that quickly allow you to automate the failover and the failback aspects in such a case of a cyber or ransomware attack. In addition to this, you can automate it even further, but through the use of RESTful APIs. So this really becomes a compelling story to address the flexibility that most people need, making sure that it's trusted, highly reliable environment and service provider, and that it is highly automated to minimize the impact of the physical resources and um, human support groups that have to be involved in the event of a disaster. And when we take a look at the recovery life cycle, you need to be focused on having cost-effective business continuity for those mission critical workloads. And Travant's going to go through this in a little more detail of how both Cloudender and Elastic Disaster Recovery operate. But at a super high level, you need to first assess your environment. If we talk back to having that plan, understanding what needs to be protected and how it's going to be protected, then when you get into your configuration and setup, you're going to install agents on those identified servers where you need to replicate into a stage and area where then we can create these blueprints that guide how your servers are going to be deployed in the event of a disaster. And then being able to quickly test those servers before the disaster event. Quite often, organizations will set up disaster recovery, but unfortunately, they only test those maybe once a year at best, sometimes once every 2 or 3 years, because the cost associated with the testing and validation of their processes can be quite high. Utilizing these tools from AWS, they're very quick. They're very easy to perform these tests. You can spin up the test servers. You can test continuity and connection, and that the replication is there, and do that in a secure test environment rather than having to go through the full drop. Now, you still want to do a full-on disaster recovery, but this allows you to very quickly, on a more frequent basis, verify that your continuity plans are working and do cover what is needed to maintain your business operations. And then once you've gone through the setup and the testing for it, then you get into your operational mode. making sure that you are getting the replication. If there's ever a problem with a replication, getting alerted. And that's where the new disaster recovery service really comes into play with the integration into things like CloudWatch and so forth, because you have better visibility into what's happening on the block replication services. Did an agent lose connectivity or not, and be able to interact with that so that you can maintain that consistency of operation. And then the most important part of this is, in the event of an issue, being able to launch into a recovery state in the cloud, only paying for those cloud services at that point when it's needed. And when it's done, being able to replicate all the data changes back to your on premise or other cloud service production environment once those have been made healthy after the event. And this works whether it's on premise to AWS through cross region or cross availability zone, or even across multiple cloud. So it gives you a wide variety for being able to establish a well-defined recovery lifecycle and being able to maintain it as your business grows. And you're going to continue to add new applications and new servers to that. And the tool allows you the flexibility of being able to interject new services, new application servers, and data points into this overall operation and quickly test that those new entries are working as expected. So with that, Sirvan, it'd be great if you just kind of walk through it at a high level, the architecture, and how does all this work, and really what makes this so advantageous to clients looking for protection against ransomware and cyber attacks and disasters.
Sure. So Cloud Endure is a software as a service solution, and as such has a central management console, like we see in the figure. Uh, this central management console manages and controls the entire workload mobility process. The management console is not a part of the replicated machine data between the source and target locations, but it serves as a control plane and a licensing server. Let's consider an example. On the left hand side, we have a customer source environment, and this environment can be any environment. It can be Microsoft Hyper-V, it can be VMware vSphere, it can be a physical on premise location, or it can be a cloud based environment. Here, the customer has two database servers with three disks attached to the top database server and two disks attached to the bottom database server. On the right-hand side, you see the target AWS account and region to which the customer wants to migrate or protect the machines into. In the target AWS account and region, the customer will need to select the replication server subnet, which would be a particular availability zone. This is referred as the staging area. The Cloud Endure staging area generally utilizes low-cost compute and storage service designed to keep the data in real-time sync with the source environment. The staging area consists of lightweight EC2 instances, which are the replication servers, staging volumes. These are EBS volumes. These can be SD1, SE1, GP2, GP3, or the newer IO1 and IO2 volumes. The staging area also consists of snapshots that are taken of your staging volumes to maintain point-in-time recovery points. Our first action would be to install the Cloud Endure agent on the source machines. The agent installation doesn't require a reboot and can be installed in an unattended fashion. Upon installation, each agent authenticates with the Cloud Endure Management Console, which in turn automatically provisions the staging area resources. We have to note that every source disk that is replicated is identified as an equally sized EBS volume, and it is created in the staging area in order to allow synchronization to occur. In this example, we can see that 5 disks are replicating from the source location, which result in 5 identically cloned EBS volumes attached to the staging area replication server. Once the agent is installed and the staging area is created, replication will begin and the data is transferred directly from the source machines to the replication server volumes. The replication path is controlled by the customer itself and may use private connectivity options such as direct connect, VPNs, or anything else that can use private connection. The staging area resources scale up and down as needed based on concurrently replicating machines and disks and are automatically managed by the Cloud Endure Management Console. Therefore, there is no maintenance operation required from the customers to manage the staging area. Cloud Endure replication servers are ephemeral resources and are automatically rotated from time to time by the Cloud Endure Management Console. Replication includes two stages. There is initial sync and there is continuous data replication. When you first install the agent, the initial sync begins. And during this time, Cloud Endure agent copies the entire content of your source disk to EBS volumes in the staging area. In parallel, Cloud Endure uses continuous replication to track any data writes that occur in real time and in asynchronous fashion copies the data to the target staging area. The continuous replication process continues indefinitely once the initial sync is completed. Now that we have the agent installed and the replication is in progress, we can configure our target machine blueprints like we discussed. These settings are within the Cloud Endure user console itself. The target blueprint is a set of configurations that define where and how the target machines are launched, such as you can select the target subnet, target security groups, instance type, volume type. You can add any tags and any other configuration that you want to do with your EC2 instance. Once the target blueprint is configured, and as long as the initial sync is complete, you can do a target launch into the AWS target region with a click in the user console. You can also perform drills to make sure that your servers are booting up properly in AWS. Cloud Endure will issue a sequence of API calls that will initiate a launch process and automatically orchestrate the target machine according to the configured target machine blueprint settings. During the target launch, Cloud Endure spins up a converter machine, which makes the machine AWS native. This includes changes to the drivers, network, OS license, and more settings, resulting in the machine's ability to boot natively in AWS. Unlike replication settings that are active as long as the replication is active, the machine converter is spun up only for specific purpose of converting the machines during the launch process, and then it's immediately terminated. Once the conversion process is done, the target machine is spun up and is ready for use. The conversion generally takes minutes to complete, so you don't have to worry about your RTOs and RPOs. So let's talk a little in detail about the DRS architecture. The DRS architecture is similar to that of Cloud Endure DR with minor differences. So AWS DRS is a lift and shift service that is access to the AWS management console. You do not have a separate console like you have for Cloud Endure DR. The replication settings and target settings are managed via EC2 launch templates, which can be accessed via the respective menus in the DRS console itself. Upon installation of the AWS DRS replication agent, the agent performs a handshake with the DRS endpoint, which is encrypted with TLS 1.3. You can use VPC endpoints to reach the DRS endpoint here. Access to public internet is not required for AWS DRS as everything falls within the AWS infrastructure, and on-prem to AWS connectivity can be managed through direct connect and private links. This is a significant security benefit. You can also leverage AWS API calls and set up monitoring using CloudWatch, CloudTrail, or set up Event Bridge. These are some major differences between Cloud Endure and DRS architectures. Everything else is, as we discussed, the blueprint settings, the staging area, everything is going to be very similar to that of Cloud Endure. Back to you, Troy.
All right, thank you. I appreciate the overview on that. So, the obvious question is, how do you get started and, how can you gain assistance with that? So, TechStream has been what we call a digital transformation expert for quite a number of years. We focus not just on software, but services where we're an AWS professional service provider, providing ongoing support and keeping your applications and your environments running at peak efficiency. And then also helping to source your environments in case you need additional resources beyond those capabilities that we provide from our traditional services and support capabilities. And we focus on AWS or Oracle platforms and also our a leader in providing Splunk services as well as Splunk on AWS. So, in addition to that, we have put together a Cloud Endure DRS offering to help organizations start to take advantage of all the capabilities that AWS provides. And we have two different flavors of this. One is a disaster recovery POC, and the second is a fresh start cloud migration. So on the DR POC, it's really taken advantage of uh, the Elastic Disaster Recovery or Cloud Endure, depending upon your particular needs and environments and requirements as we outlined earlier. And this is geared to operate within a week. So we'll come in and work with you to set up the environment, configure the Cloud Endure or the disaster recovery services, and we'll target 3 servers and associated drives to set up the disaster recovery so that you can see this in action and demonstrate cutover services and some of the key features of these tools. The Fresh Start migration, again, like the DRPOC, is set up for a 1 week engagement where we'll come in and set up your AWS infrastructure, configure the AWS migration services, which is another tool offered by AWS designed specifically for not just being able to do block level replication, but migrating workloads into the cloud and work in a development or QA environment to move up to 2 applications plus a supporting database into utilizing these technologies and demonstrate the capabilities of these services in that environment with you. So these are 2 great ways to get started to understand the capabilities of the different services that AWS offers. So we really appreciate you listening to the presentation today, and we welcome any questions that you may have. Please feel free to reach out to us at any time. You can contact us directly via phone at 678-708-4900, or you can request additional information by simply emailing us at info@techstream.com. Trevon, I really appreciate you joining us today for this session. You brought some very insightful information that I think is going to help our clients understand how Cloud Endure and disaster recovery can enable our customers to create environments that are uh, better protected against uh, physical outages as well as outages that derive from various forms of cyber attack. And again, really appreciate all of you listening in the session. Please reach out to us if you have any questions, and we look forward to hearing from you. Have a great day.
Thanks, Troy.